Remember how they talked about people who will be selling shirts in there? Yes or no? Okay. So there's going to be a table in there during the lunch periods, and it's twofold. If you're able to come and help during any of those free times, we would love, absolutely love, to have you come and help. Tells you what the different days themselves are. I'll repost the link, but it was already posted once in Google Classroom. If you're able to go through and help, it would be wonderful. There's pretty much two things that you'll be doing. There'll be a bunch of shirts there, and people walk up to you. I think the shirts are like $2 or $3 maybe. We'll let you know closer to the time. Someone will walk up and say, I would like to buy a shirt. And you will look at them and say, what size? And then they'll go, medium. And then you'll hand them the medium, and then they may go, thank you, here's $3. Or the other end would be, oh my goodness, this is too small or big. Perhaps can I try another size? And then you'll say, what size would you like to have? And so on until the customer is happy. Then the other end of it is, raise your hand if you know who Dr. Enk is. Okay, so Dr. Enk is helping to coordinate a donation of, they didn't mention this yet, but it will be coming up, a food donation to Webster Community Cupboard or Webster Food Pantry. It's whichever one is just, well, is local to Webster, so it's not like it's a United Way thing where your individual donation will go like to everywhere. This tends to stay like actually within Webster. So there's two ways that people approach this, and we hope that you're not the latter, although I am. You can probably guess which one I am out of these two donation groups. There is a group who literally once a year will open up their pantry and, well, we'll say this. There's a group of very, very good people who will go to the store and be like, hey, there's a bunch of stuff, you know, we're going to throw 10, 5, $20 worth, whatever, stuff in the cart. And darling, you're going to be bringing that to school on Monday. We'll put it in a bag for you, at which point the kid says, great, and sort of it's the end of the conversation. Then there's another group, which I tend to fall into, who goes through and opens up their pantry and is like, yeah, I was really ambitious on that green bean sale. Kind of bought too many cans. I'm probably never going to get through this, but I'm sure somebody can find something to use them for. Or maybe I shouldn't have bought, 17 packages of brownie mix because that's really bad for me, but I'm sure that there's somebody out there who could find a good use for them instead of letting it rot in my cabinet. Not that I would do that, but in any case, I tend to empty out my full pantry at that point and sort of start anew. You could be one of those people as well. But if you're if you're stationed at our collection booth, you'll either be dealing with somebody coming up looking to buy a shirt, which there may be probably 5 in the lunch half periods. And the other end is somebody might come up to you with a bag of food, which point you'll say, it goes in there, and then that's it. Okay? If you could be a helping hero, it would be a wonderful help to the whole building. We'll go over something that we'll do, hopefully for all of you at the end. We went over this before, though, right? Yes or no? Okay. I would assume so, seeing as some of you are on here. One more thing quickly. This has been on my desk forever. This was actually part of One Warrior Week a couple of years ago. They had somebody from the community had collected tons and tons of Beanie Babies and then realized that they're essentially, do you remember what Beanie Babies were? Or is that, okay. So then they realized that this is not my retirement portfolio. They're really not worth a lot. They just sort of collect dust in the corner, and pardon my language, why the hell do I need this many? And so what the person ended up doing was donating them to Schrader to go through and sell. Somebody bought me one that I still keep on my desk that looks like my little Rockito, and it makes me happy every day. Someone else bought me this, and I'm not quite sure why. But would anyone like this Beanie Baby? Would there be somebody who's willing to give this, what is this, a goose? Is that right? Swan? Anybody willing to give this swan a good home? All right. This is how things end up here. There we go.
I'll think about it.
All right. Think about it. Here's another one, by the way. Miss Goodwine gave me this, and I have absolutely no use for it at all. But some of you might. This is like apparently, she was at a conference where this came up. This is like a stand for your phone and or iPad. Would anybody like one of these?
Oh, no.
Okay. You can actually, you know what maybe we can do? See? Does this work? See?
Only thing is people will be looking at your
What? Listen, that's not my problem. I'm just trying to get stuff off my desk. This is how you're going to learn today. All right, so we left off last time on question D. What I need all of us to understand is we're going to burn through our stuff kind of quickly today. We'll do the review as well. Understand that we're going to burn through our stuff kind of quickly today. We've got this, then next class that you have is review, and then your exam. So there is another exam that you're going to have before the end of the quarter. And again, please expect it to be cumulative overall. There's going to be some awkward questions in there. Make sure you know your work, yada, yada. I would fill in today's date on the outside. Today we're going to start technically at day 5 stuff, and you want to put today's date as 4-3. Looking at what we have from over here, here are our questions. Let me lock this in place. Looking at the first question, what would we go through and do to algebraically determine what the answer to this question is? What would we go through and do? Taylor? For what? There we go. So I'm going to set it up. 51200 is equal to 100 times 2 raised to the t power. What do we do from here then, Jason? So hopefully we don't need a calculator for that. We're going to divide both sides by 100. And when we do that, you're left with 5. The zeros drop out. 512 is equal to 2 raised to the t power. What do we do once we get here, Jensen? Okay, so what's this going to look like in log form? So go into your calculator and evaluate out log base 2 of 512. What'd you get? 9 is equal to t. And that's your answer. It is not your answer. Why not? Hands up, please, if we can answer that. Yeah? So this is 9 periods. Each period is 15 minutes. So what'd you get as your final answer? And what'd you say it was what?
15 minutes, not 45.
Oh, 15 minutes, sorry. So 15 times 9, and you got 135? Questions on that? Circle your final answer and you're done. Next one up, we need to solve this equation out. Express your answer in simplest A plus BI form. Allison, what would you go through and do in order to answer this out? There's 2 ways that we can do this. You can do it one of 2. One is quadratic formula. Who remembers what the other way is going to be? Who remembers what the other way is? Why does this allow us, why would this be, why would completing the square be a viable option in this case? Why does this set up easily to do completing the square? Because not every question will. Michael? The B value is even, and what else needs to happen, Tyler? The A value's got to be 1. So you went through and did it with quad formula, so let's do it that way. You get x is equal to, and then we list out the shell of the quadratic formula, and we're going to plug in numbers. What value is going to go on that left one here? Alyssa, what would you put here? And down here? And what'd you get for your discriminant? Negative 24? Okay. What do we do now from here? Hands up, please, if you can tell me. Oh, really? Seriously? Wow. Wow. Johannes, what do you want to say? Because what perfect square did you take out? Negative 4, and square root of negative 4 is how much? What's it going to reduce to? To I. Don't forget the I. You're not done yet, though. Why are you not done yet? Okay, and what do you get? Now, this is right. Just From a math perspective, I hate when I see this because it indicates to me you're a formula robot. What do you not want to really see when you're doing this if you're me? What do you want to see? Yeah. The over 1 part. We hope that you know it's already over 1. We're not. Maybe. Yep.
On the regions, don't they not like it when you put next to x plus minus in it?
No, they don't care.
Oh, okay. Or I thought you did.
Listen, I care all the time because when you're doing this out, if you're me, I'm looking at that and I'm going, this person clearly understands that they know that there's 2 answers. If I don't see the plus or minus, you lose credit. You understand what I'm saying? Like, we need you to understand that when you take the square root, you're getting 2 answers out. I don't need you to separate them if that's what you were asking.
Oh, okay.
Like 1 plus I root 6, 1 minus. Although, understand, the Reach is trending towards that and saying which one of these would be an answer, which one it would be 1 plus I root 6, 1 or 1 minus I root 6, but not both would be a choice. Okay? We've got to recognize that both of those are answer choices. Take a look, please, at that relation, which statement is true. Now, in order to answer this, you've got to know what this here means. Hands up, please, if you can tell me what that notation is telling us. Johan, yeah, you want it. No. What does this notation mean? What's that called? Who remembers? Yeah. Yeah, it's the inverse. So if I'm doing this, that's what set A looks like, set A inverse. So as long as we're doing it, what would A inverse look like, Johan? 2, 3, what else? Okay? Which answer did you say? Why would you say that A inverse is not a function? Yeah, one x value has 2 output values, or one input has 2 outputs. By the way, I immediately knew that from looking at the beginning. Look at a function A. A is going to be a function, but what criteria does A not meet? What criteria does A not meet? Go ahead. That's if you plot them out. I look at this and say it's not A. Yeah. Yeah, that's what she said. It's not 1-to-1. How do you know it's not 1-to-1? Yeah, 2, there's 2, or the output value of 2 is used more than once. Now, and I will tell you this, we're back over to here. Read out question D right now. Whatever page, what page is this on, loves? 22, go to page 22. Read out D. Remember we learned there's situations that are and, there's times when we're multiplying for our probabilities, and there's times when it's something given something else. So look at question D, and you tell me, let's do a setup on it, and let's see what we can go through and get. Chloe, what do you think the setup on this is going to look like? We may get the same answer from this, but I don't think so. Is Tyler?
So since we've already given the one the first time, we just have to find the probability of it.
Yeah, and actually, well, yes. What we have right now is a conditional probability, where it's something given something. So we need to do this as if the first jelly bean that was selected was a lemon, what's the probability that the second one would be a lemon as well? Now, there's a direct way that we can get it. We're sort of going to remove something that's implied there, but I'm hoping that you recognize this is lemon given lemon. So when we do this out, you're finding the probability of getting a lemon. The bar means given, that you already got a lemon in the first place. Now, looking at this, I'd say to figure out the probability of lemon given lemon, I'd have to do getting a lemon and a lemon over the probability of getting a lemon itself. So let's do this out. Lemon and lemon. Well, if I did that, look at the numerator first. What's the probability of getting a lemon on the first pick, Maddie? Times, with and we multiply, 16 over 36 times. Now, it's a lemon the first time and a lemon the second time. So you've had a lemon the first time. Now let's go to the other half of the and. What's the probability of getting a second one? 15 over? Nope. 35, yeah, because you took one out. Over, what's the probability of getting a lemon overall going to be? Think about it. You're making one discrete individual selection, Chloe. 16 over 36. Now, just in terms of the math, you could go into your calculator to do this. I hope you wouldn't. Why do I hope that you don't need a calculator to do this out, Jason?
16 out 36 reduced, you can
There you go. Final answer would be 15 over 35. Based on what Tyler said, from what I understand, he said, we already know that a lemon has occurred. So what's the probability of getting a lemon a second try? You got that immediately. Is that right? Did yours work out that way or no? I can't remember what you were saying. I didn't think it sounded like it was there. If it's something and something, you approach it with multiplication. The other, and if it's an or, you've got to take into consideration that the positions could flip-flop. The other end of things, though, is going through and recognizing when you have something given something, and that's an example of conditional probability. Questions on that? All right, let's go over and try the next page. Softball playoffs, double elimination system is used. The Lionesses are in the playoffs. They have a 60% chance of winning their first game and then a 50% chance of winning their second. If they lose the first game and go into a loser's bracket, they have an 80% chance of winning that game. Create a tree diagram for this situation. So how many games are we looking at, or how many branches, I guess, will this have to start? Yeah, 2. And what are the options going to be? Well, there's a win and a loss. So I go in and I'd start off. They could either win or lose. Now, what's the probabilities that we're going to affix to this? Jonathan?
For the winning is 60%, so they're
Okay. And then the lose would be what? Now, they win their first game. You've got 2 possibilities after that. You either win the second or lose that. Now, what's the probability that they win their second game given that they win their first? Peter? 0.5. And then what's the probability that they lose their first game given, or second game given that they won their first? Okay? So, let's look now at the second half of this. And looking at what's there, Jack, what am I going to draw coming off of this loss here? Okay? What probability goes here? 0.8. And what's the probability then that goes down here? 0.2. Questions on that? So we created the tree diagram. What's the probability that they'll go undefeated in the playoffs? So think about the setup, though. Let's start off with that. If, in order for them to win the playoffs, what needs to happen? Win the first time, so we need the probability of a win. And, is it an and or an or? And, win and what else? Okay, so win and win. How would I compute that out? What would I have to go through and do? Emily, what do you say? 0.6 times 0.5. And what do we get when we multiply those together? There you go. Questions on that? What's the probability that they only win one game? Now, think about what the setup on that's going to look like. Who can tell me the probability that they only win one game? What's the setup on that going to look like? Who can tell me? We got one. Two people. We'll wait for six. What would our setup look like to figure this out? Think about the individual outcomes, and we're going to have to add them together. We got three people. Emma Kay, what's an outcome that could happen that would be successful? Okay, so the probability of a win and a loss, or what else? So let's do these two out. Trevor, how would you compute the probability of a win and a loss?
You do 0.6 times 0.5.
Okay, and then, since it's an or, we're going to add it. What about the probability of a loss and a win?
0.4 times 0.8.
Okay, go into your calculators right now and let's compute that out. And hands up, please, if you can tell me what that's going to be. Jonathan? Questions on that? Now, this next one I'm actually going to approach in sort of an indirect route. There's more than one way that we could do this out. It says, what's the probability that they will win at least one game? So, in order for them to win at least one game, who can tell me one successful outcome that would satisfy this equation? Or, sorry, satisfy this question. Chase? Win and win works. What's another outcome that would satisfy? Win and lose, and what's the last one? Lose and win. There's only one outcome that isn't favorable to us. What is the one outcome that we need to exclude from this? Now, there's two ways that we can look at this. What do all of these probabilities added together go through and add up to? Hands up, please, if you can tell me what all of them are going to add to. There's really a shortcut to computing out what the answer to this is. We could add together those three outcomes that we described in the beginning that were successful, or what else could we do? Peter? And do what to it? Yeah, I could do it this way, and when I was doing it, I did the probability of, or sorry, I did 1 minus, like Peter just said. 1 minus the probability of lose and lose. Why? Because that catches all of the other ones that are in there. Because that's the only one that's not successful. Win-win would be included in the answer to this. Win-lose and lose-win. So let's look at the probability of getting 2 losses. Noah, what's the probability of getting a loss the first time? And then and a loss the second time would be what? So I do 1 minus the product of those two. And what value, Tyler, is that going to come out to give you?
0.9.
And 0.92, is that right? That we got? Okay. Now, if you had done the other 3 and added them together, would you get to the same thing? And the answer is yes. And actually, you could tell that you already have 2 of the other outcomes together. You've got a win and a loss, or a loss and a win. What other one would you need to compute? Win and win, and it's going to give you the same thing. What's the probability that they lose both playoff games? Well, what do we need to compute in order to get an answer for that? Alexa? Probability of a what? Yeah, lose and lose. So what's the probability that they lose the first game? times, which is going to be questions on this? So these start getting a little bit repetitive, okay? I'm actually going to try to jump ahead, and we're going to come back once I make sure that we get all of our stuff for day 5 done. We'll probably go back and start doing everything we didn't do in the other sections. Taking a look at what's here, 2 events are going to be independent if knowing that one event occurs does not change the probability that the other occurs. So 2 events are independent if knowing that one occurs doesn't change the probability that the other occurs. So, independent events are rolling a die and getting a 5, flipping a coin and getting heads. It doesn't matter what happens on the die, it won't change the probability of getting a head on the coin. You see how those 2 things aren't connected to each other? Where we've done things before where, in fact, those probabilities do change. Like, if you have a set of something and I go in and I make a pick, I take 1 out. You can think of it like your cards in the deck now. If we go through and there's, 20 some odd of you in here, if I go in and take somebody's card out for the day, and then I'm going to go in and take yours, that is your probabilities depending on what happened beforehand. Now, dependent events are picking cards without replacements, like we just said. If we get a 4 the first try, I'm going to go in, and there's 1 less 4 and 1 less card in the deck overall. If I pick a 4 on the first draw, and that makes the probability of getting a 4 on the second draw smaller, because there's 1 less 4 in the deck. Does that make sense? Think about if the events are independent or dependent on each other. Here's our way to go through and check. The events are independent if the probability of P given A is the same as the probability of B itself. And there's another way of doing it, well, and what that looks like in practice, if you're trying to see. Probability of B given A means the probability of B and A over the probability of A is going to be equal to the probability of B. If those are equal, you've shown independence. The other way to go through and show independence, this is one way. The second way of showing independence is going through and saying the probability of B and A is going to be equal to the probability of A times the probability of B. Questions on that? That's how you go through and check to see if they are independent. All right, let's take a look at the next question. Number 1, a single die is rolled. Let A be the event. A number is greater than 3 is rolled. Let B be the event that an even number is rolled. Are they independent? So, looking at what we have, let's look, well, this we always bring up just on a side note. How many on a single die? Do you know what a die is? Okay, it's a dice. How many sides does a dice have? Just so we're all clear. 6. What are the numbers on a dice? 1 through 6. All right. So, in order to figure out if events A and B are independent, I would go through and say, well, let's figure out. Let's do this. Probability of B given A, and see if it's equal to the probability of event B. So let's evaluate the probability of B given A. If it's B given A, to evaluate this out, we would go through and say, well, this is the probability of B and A over the probability of B. Oh, wait, sorry. Probability of what? It should be the A, sorry. And see if that's equal to the probability of the event itself, B. Now, let's think about this. What is the probability of getting B and A? Well, go back and look. B and A, I mean, we can do this just by a simple check. By the way, I did this on the side when I did mine. What are the events, or what are the favorable outcomes that are in A? What are the favorable outcomes that are in A? Go ahead. 4, 5, and 6. What are the favorable outcomes that are in B? Hands up, please, if you tell me what are the favorable outcomes. Yep. Perfect. So, what's the probability of getting an event that satisfies both of these? No. When I did mine, yep. No. Looking at the probability of B and A, I went through how many members satisfy B and A? 2, right? What are the members that satisfy both? 4 and 6. So what's the probability that we go through and get a 4 and a 6? Oh, I'm sorry. Oh, you know why? If you said that, I'm sorry. I had it down as not being reduced. I'm sorry. That's why I don't like, by the way, just so you know, when I do my workout, I don't reduce until the very end, even if necessary, because I don't want you to lose the fact of how many outcomes there are. Reducing that in your head, some people will be going, well, where the heck did that 3 come from? I thought there were 6 sides of a dice. Sorry if that's why. Now, what's the probability of A happening next? Hands up, please, if you can tell me what the probability of A happening would be. Really? 2 people? No. 3 over 6. So what is this going to come out to be on the left-hand side? What would we be left with? There's a quick shortcut, by the way, on this that you can go through. You'll get the answer on your calculator. Does anybody know the shortcut we can do on these? The setup there on that fraction. Complex fraction right now. You can drop something right now. What is it? Yeah, the 6 over 6, you can, when you multiply by the reciprocal, yada, yada. This would leave me with probability of 2/3. What's the probability of just event B occurring? Hands up, please, if you can tell me what the probability of event B occurring is going to be. Yeah. Yeah, 3 out of 6. Are these equal to each other, yes or no? No. Since they are not equal to each other, what can we conclude? A and B are not independent events. Please understand that we did this out, and I actually had to grade this question on the last Regents exam. Again, we can all have some patience with each other. If you have questions, I'll be more than happy to answer. This, to me, is diabolical. Like, I have to go through and do this out 3 or 4 times in a minute. Is this right? Is this right? And I'm calling up my friends from Fayetteville, Manlius, from Pittsburgh, and going, is this right? Did I get it right? And they're like, yes, you're done. I'm like, oh, okay. They don't let me go. Questions on this, though? Yes.
How did you get 2 out of 6 for
The probability of A and B?
Yeah.
Look at the number of, how many total outcomes do we have when we roll a die?
I guess 6.
Nope.
I mean,
You have 6 outcomes total. Okay.
6 plus 8.
Yeah, and you notice it's not 2 separate dice being rolled. How many dice are there? It's just one. So what's the probability of A happening? Well, how many events are greater than 3? There's 3 of them, 4, 5, and 6, right? And then how many events are in outcome B?
Two.
No.
Or, well, two of them. Then.
No. 3. How many events are in outcome B? There'd be 3. The numbers would be 2, 4, and 6. So A and B is the outcomes that satisfy both. How many outcomes satisfy the condition set forth in A and B? 2. How many outcomes meet the condition set forth in A? 3. So the probability of A and B occurring is 2 over 6. The probability of A in and of itself occurring is 3 out of 6. Does that equal the probability of B? No. So are they independent events? They're not independent. If it doesn't meet that, it's not independent. Questions on that? All right, go through right now. Give question 2 a read and a try right now. Now, here's the stuff that I'm able to pull out from what's given. And the setup on this is going to be a little bit awkward, in particular because there's a bunch of conditions that are sort of set up. So I made HB represent hearing problems. L is going to be listening to loud music. Looking at here, how did I know the probability of H and L? Hands up, please, if you can tell me how I knew that. Yeah. 12% have hearing problems and listen to loud music. That's where this, in and of itself, will come from. The next part is, suppose that, from this group, 60% listen to loud music on the headphones, so listen to loud is going to be 60%. Now, the other piece of it, though, is not given to you directly. It says 85% were found to have, suppose that the sample reported that 60% listen to the loud music, and 85% had no hearing problems. So that's another issue. 85% don't have hearing problems. So what's the probability of having a hearing problem? It's 15%. Now, how can we go about showing if these events are related or if they are not? Well, I guess there's more than one way that we can do this, but I view it as the other example from before, because it's not something given something really. Let's find out what these events are. I went through and did it as the probability of headphones and hearing loss, is that equal to the probability of a hearing problem and the probability of listening to headphones? Are those equal to each other? Let's go through and figure out what's the probability of having a hearing problem and listening to loud music in your headphone. Peter? 0.12. Is that equal to what's the probability of having a hearing problem? Jack? Times what's the probability of listening to loud music? 0.6. What do we get when we multiply those on the right together? Haley? So, do these equal each other? No. If they do not equal each other, hands up please if you can tell me what we've just shown. If they don't equal each other, what did they just show?
That's the two things.
Questions on this? Let's go over to the next one.
We got 2 or 3 more left.
Take a look at example 3 and go through right now, loves, and read out example 3, please. And give 3 a try. So looking at this, I'm going to label this as my S. My snow is going to be S. My R is going to be rain. And it's asking, oh, by the way, how many total members of this set are there going to be? Hands up, please, if you can tell me how many total members. 31. Keep that in mind, somewhere on there. We need to know that there's 31 events on there. Are the events of having snow and rain independent? So, you tell me, Jensen, how do you want to show whether or not it's independent? There's 2 ways that you can do it. You get to pick. Which one do you want to do?
Multiply the like snow and rain, and then see if they're equal. Like snow. If you multiply snow or rain individually.
Yes, let's see snow. So you're saying do the probability of snow and rain and see if it's equal to the probability of snow times the probability of rain? Is that how you did it? Okay, so when you did that, what was your value that you got? What's the probability of getting snow and rain? 5 out of 31. And what's the probability of getting snow? And the probability of getting rain? And when you multiply those together, what do you get on the right-hand side? Yeah. So, we got 24. Oh, wait a minute. I think, yeah, these guys are wrong. Who's got the modification that we want to go through and make on here? So we did this out. What was the error? Hands up, please, if you can tell me there. And it's an easy one to make. What's the error that was done on here, Chuck?
He has 3 out of 31 and 8 out of 31.
Yeah.
Have snow and rain.
So what's the probability of snow then?
8 over 31.
There you go. Because it's everything in that S circle, not just the exclusive snow. And then what's the probability of rain? Did you do it this way as well? What did you get then on the right-hand side?
I didn't finish it.
Who can tell me what this is going to come out to be? I got my, yeah.
4 over 9.
So are those equal to each other, yes or no? So if that's the case, are these independent or dependent? Yeah, these are dependent. Which I guess is another way of saying. Okay. Questions on that? Let's take a look now, please, at question number 4. We're going to use this table, and it says what's the probability, and this is total overall generic. Actually, you know what? You do this. Do out question 4 right now. Time goes by so quickly in here. You probably feel like it's going slowly. I thought we had like 25 minutes left. Yeah. Yep. You mean something like this? You could use either or. Okay? They both get to the same end. Okay? You could use either one. But keep in mind, the other one is something given something else. So make sure you're familiar with both. Alyssa, what'd you get for the A part of this? Yeah, so the probability that the person is between 31 and 45, and you correctly said it's going to be 89 over 207. Did I hear you right?
Yeah.
Great. What's the probability that a person makes over 50, that a person who makes over 50,000 will be that old? Now, here's one that we've got to go through and take into account. What's the setup of this going to look like? Really? You want to give it a try?
So just the people that are 31 or 45 that make 50,000, which is 35 people over the total that make 50,000.
Yeah, when I did this out, I did it as a then, like a condition, then a condition, but you're going to get that reduction out. I thought my friend Jason before mentioned that we have something that's going to reduce out. It's the probability that a person makes over that will be that. So I'm trying to find the probability that someone's 31 to 45, given that they make over 50,000 a year. And what did you get that ended up being? Well, it would be how many? Yeah. Based on your answers above, is annual income independent from age? Is that the case? And I would go through and say no, given that we know the probability that someone is 31 to 45 and makes over $50,000 a year. Does that equal the probability that the person is 31 to 45? Are they equal to each other, yes or no? No. Here's our last one that hopefully we can do pretty quickly. Spinner is going to spin. E is the number of events. Or sorry, let E be the event of getting an even. S be the event of getting a perfect square. Are the two events independent? So when I did this out, I said, what's the probability of getting an even and a perfect square, and check to see if that's the same as what? If we're checking to see if they're dependent, what would the other half of this have to look like then? One person? Come on. Come on. Michael? No. Even times a square. That's just from the formula before. So, looking at this, what's the probability of getting an even and perfect square number? Hands up, please, if you can tell me. Probability of getting an even and a perfect square. Yes? No? What was your other one? What event satisfied that? I only got... Yeah, one of it. The only one that's an even and a perfect square is going to be 4. Yeah. So what's the probability then of getting an even number? I'll reduce it down. It's a half. Times what's the probability of getting a perfect square? What perfect squares are in that list? Jason? 1 and 4. So that would be 1/4, which would be 1/8 is equal to, multiplying those would give me 1/8. Are these events independent? Okay. Questions on that? Now, what we're going to tell you all to go through and do, I start reviewing right now. Please understand that your homework for you all, and some of you haven't done much, if any, take a look. Go over, please, and look at, I think it's number, yeah, take a look at page 45 and 46. That's what your homework is going to be, those two, 45 and 46. I can message out the answers tonight if you would like, but get 45, page 45 and page 46 done. Next time we have class, you have review, and then after that, you have your unit exam. So what day is your unit exam going to be on? What's that? Thursday? Wonderful.